Hello students and welcome back. I know you've missed my voice. That TED Talk was great, but I mean, can you really compete with the amazing Mr. Larkin? No. So let's get right into it. So we got phases of matter. So I know this is going to have to do something to do with matter, which is mass. I know that from a different class. I'm not really sure what a phase is, so I'm putting a question mark there. Alright, it says the three main states of matter are gases, so there's three. Gases, liquids, and solids. I'm already glancing down here, and I see there's a diagram with each of those three right down here. The main difference between each phase, okay, so here it says the three main states of matter, and then here it says between each phase. So I think they're talking about the same thing. So I want to capture that. I want to say a phase is a state of matter. All right. So it says the main difference between each phase is the degree of random molecular motion. That sounds important. Random molecular motion that occurs. Random molecular motion means that there's no set pattern. Okay, so that makes sense. Random means no pattern. So no set pattern to the way the molecules in a solid, liquid, or gas move. They just move randomly. Yeah, no set pattern. That makes sense. The molecules in a solid may vibrate but tend to retain. So I know retain means keep their overall structure until enough heat or energy, so energy is heat, is added to break the forces holding them together. Liquids have more, so more than solid, random molecular motion, but not as much as gases, which have the most. So now I'm looking at this. Yeah, so from the reading that said this is vibration, right? This is vibration right here. So the structure is the same, but they're just vibrating. And then liquid here, it says they can move around. They have more random motion, but then gases have the most. So low, medium, high basically is what this arrow seems to be telling me. Okay, so I got my three phases using my vocabulary right here. I got solid, liquid, and gas. Let's keep reading. So this next part of the page is talking about diffusion. Again, I have no idea what diffusion means. Oh, well, it looks like it's going to tell me. So diffusion refers to the process. Okay, process, I know that's an action. So the process by which particles intermingle. Intermingle. Well, I know mingle is mix. I don't know what inter, but so I'm just let's read it as mix. So by which particles mix as a result of their kinetic energy of random motion. So random motion, that reminds me of random molecular motion. And then kinetic energy, I don't know what that means, and I'm just going to assume this mix. So the mixing because of random molecular motion. Okay, we'll have to define this at the end. Kinetic energy is energy related to movement. Okay, well that just answers that. Since I wondered about that earlier, I'm going to capture it. So kinetic energy is energy related to movement. Okay, what else does it say now? Consider two containers of gas, A and B. Well, here's A and B to the side, so I think that's what they mean. Separated by a partition. I don't know what a partition is. Actually, you know what? Let's just look this up. Okay, so partition lyrics. No, I'm not talking about the Beyonce song. Okay, definition. There we go. So it says, especially with reference to a country, the action or state of dividing or being divided into parts. Divide into parts. Okay, so a partition is when we divide something into parts. So this right here, this must be the partition because it's separating A and B. Okay, it says the particles of both gases are in constant motion. Again, I'm thinking random molecular motion, and make numerous, so many, collisions with the partition. So, yeah, that's hitting, okay. If the partition is removed, as in the lower illustration, the gases will mix. Here I'm thinking intermingle. Yeah, I think so. Because of the random velocities of their molecules. So here, mix because random velocities, random molecular motion. In time, a uniform, so I know uniform from school means same. A same mixture of A and B molecules will be produced in the container. Because each gas is moving randomly. Boy, I'm seeing a lot of random here. Sometimes bumping into other particles and going backwards. Diffusion can take a while. Okay, so diffusion takes a while. The tendency toward diffusion is very strong, even at room temperature, because of the high particle velocities, so high velocities, associated with the kinetic energy. And again, I know kinetic energy is the energy related to movement, so high energy, high velocities. The faster the particles move, the faster they diffuse. Okay, we need to define diffuse, because this definition right here is not doing it for me. So diffusion, here it says the process by which particles intermingle, I'm going to say it's mix, as a result of their kinetic energy of random molecular motion. So I'm just going to say the process of mixing because of, see, as a result, it's just because of, and then random molecular motion. So I'm just going to put that as my little definition. So the process of mixing because of random molecular motion. All right, that was a sexy read. Nicely done. See you in class.